Hello there everybody. Today we're going to be learning about how to add more than two fractions together. Here are 3 get ready questions to prepare us for that learning. Give them a go. Let's have a look at our answers. Number 1. To start with, it looks like we've got lots of exchanging to do here. But because we're just adding those 3 numbers, we can rearrange the addition. If we rearrange it like that, we can see now we have a number bond to 100 there. Therefore we have 100 and 77, which is really quite straightforward. 177. And of course we can use that idea of being able to rearrange addition sentences when we're adding fractions, just like we can do when we're adding whole numbers. Number 2. Here we have 3 fractions to add together. So we need to find a common denominator. Hopefully we can see that 1/12 can stay as it is. So 2/3 would become 8/12 and 1/6 would become 2/12. And then we can add 8/12, add that 1/12, add 2/12. We can see from the bar model is equal to 11/12. And number 3, some practice of equivalent fractions, which is still really important when we're adding 3 or more fractions together. 3/7 is equal to 9/21, and 3/7 is also equal to 15/35. The skills that we've developed when adding 2 fractions together, we're going to use now when we're adding more than 2 fractions. Here we have 3 fractions to add together: 3/16, 1/4, and 1/2. And I'm sure we're getting really confident now with being able to find that common denominator to allow us to add. We can see the connection between 16, 4 and 2. In particular, 16 is a multiple of 4 and 2. Therefore, we're going to keep 3/16 the same and write 1/4 in 16ths and 1/2 in 16ths. To write 1/4 in 16ths, we need to multiply numerator and denominator by 4. That's going to be 4/16. 1/2 in 16ths, well, we know that 8 is half of 16, and therefore 8/16 is the equivalent fraction to 1/2. And now we can add the numerators. 3/16 is shown on the bar model. Add 4/16, add 8/16, that's going to be equal to 15/16. Over to you to have a go at that question. Here we need to write 1/2 and 1/6 in 24ths. 1/2 in 24ths is 12/24, because 12 is half of 24. And 1/6 in 24ths, we'd need to multiply numerator and denominator by 4. Therefore, 4/24. And now we can add. We already have 3/24 shown on the bar model. We need to add 12/24 and another 4/24. We can count up and see we have 19/24. Rather than having to count all 19, of course, we could count back from 24/24, and we can see we've got 5 less, so we must have 19/24 there. Here we have a problem. Dexter eats 3/14 of a cake. Eva eats 1/7 of the same cake. And Mo eats half of the same cake. How much of the cake is eaten? Over to you. Have a think about the number sentence that you'd need to write to show that problem, and how you'd go around tackling it. The number sentence will be the addition, won't it? So it'll be Dexter's part, 3/14, Eva's part, 1/7, and Mo's part, 1/2. And then we need to think about our equivalent fractions. We're going to keep 3/14 the same. We're going to write 1/7 and 1/2 in 14ths. That's going to be 2/14 and 7/14, of course, because 7 is half of 14. Now we can add our numerators. However, I wouldn't work left to right here. I would do 3/14 add 7/14 first, because that's a nice number bond to 10. So that's 10/14, add another 2/14, is 12/14. And you may be able to see we can write that in a simpler fraction by using an equivalent fractions, 6/7. We could also show that in a part-whole model, like this. We've seen that the whole of the cake that was eaten was 6/7, made up of Dexter's part, 3/14, Eva's part, 1/7, and Mo's part, 1/2. Over to you to complete questions 1 to 4 on the worksheet. Here we have one of these missing digit problems. 7/30ths, add 1/6, add some number of fifths, is equal to 3/5. How are we going to tackle this? First of all, because we're adding fractions, it will be useful to use the idea of the common denominator. We can see here that 6 and 5 are both factors of 30, and therefore 30 can become our denominator. We'll keep 7/30ths as it is, and we'll write 1/6 in 30ths, which is 5/30ths, because we've multiplied numerator and denominator by 5. We're also going to write the missing digit fraction in 30ths, like that. And then we're going to write our, shall we say, the answer, the 3/5 in 30ths, like that, because we multiplied their numerator and denominator by 6. We can see, therefore, that 7/30ths, add 5/30ths, add a mystery number of 30ths, must equal 18/30ths. Let's show that in a part-whole model. The whole is 18/30ths, and we have two known parts, 7/30ths and 5/30ths, and the unknown part. Well, 7 add 5 is equal to 12. What do we have to add to 12 to equal 18? It's going to be 6, isn't it? 6/30ths, and we can check that. By adding up 7, 5 and 6, we'll get 18. And of course we're dealing with 30ths, 18/30ths. Therefore we can write 6 there. But what are we going to write in the actual answer box, in that original number sentence? We're not going to write 6, are we? Because we need to convert that 6/30ths into a fraction where 5 is the denominator. To do that, we need to divide 30 by 6 to get 5. So we're going to divide 6 by 6 to equal 1. Have a think and have a go at this similar question. Here, you may have chosen to put the fractions into 28ths. However, you may have noticed that we can also put the fractions into 7ths, because we could have a mystery number of 7ths, add 2/7ths, add 1/7 has stayed the same. Therefore, we have 2/7 add 1/7 is equal to 3/7, so we need another 2/7 to equal 5/7 in total. 2/7 add 2/7 add 1/7 is equal to 5/7. Then, of course, we have to write that 2/7 in 14ths, so it's going to be 4/14 as our answer. You're now ready to finish off the worksheet for the lesson. Have a go at questions 5 and 6.